Hello everyone. In our last video we discussed about Coulomb's law, and we know the force can be calculated between the two charges by using Coulomb's law, that is F is equal to K Q1 Q2 by R square, where Q1 is magnitude of charge on one and Q2 is magnitude of charge on the another one, and R is the distance between the two charges. Now in this video I want to show you how to find the direction of force acting between the two charges. Imagine these are two charges, one is positive and another one is negative, and the magnitude of both the charges is equal but opposite in nature. So this one, just to denote, I will take like 2 microcoulomb of charge, and this one also 2 microcoulomb of charge, but it's negative, and this one is positive. If I keep a charge somewhere here in between the two charges at the midpoint, let's say this P is the midpoint where a charge is kept, and let's say the magnitude of this charge is 4 microcoulomb. 4 microcoulomb. And what we are trying to find is what would be the direction of force acting on this 4 microcoulomb charge because of this 2 microcoulomb charge kept right side to point P and plus 2 microcoulomb charge kept left side of the point P. So we know electric field points outward from the positive charge and electric field points inward from the negative charge. And here this 4 microcoulomb charge, I have not written the sign, but this is positive charge. So positive charge here, positive charge here, they both will repel each other. So assume that this 2 microcoulomb charge is bound to something, so it's fixed, and this 4 microcoulomb charge can move in presence of force. So the force which acts on this 4 microcoulomb charge will point towards the right side because of the repulsion between the two charges. Now this charge is negative, minus 2 microcoulomb charge is negative, plus 4 microcoulomb charge is positive. So unlike charges, they attract each other. In that case, the charge will again be experiencing force towards the right side. So the force due to positive charge and the force due to negative charge, they both are pointing in same direction, that is towards the right side. So the direction of force experienced by this 4 microcoulomb charge would be towards the right side. Similarly, if we just change the nature of charge, for example, if I keep a charge here and this is positive and this one is negative, and this is the line joining the two charges, and here I have kept a negative charge of 4 microcoulomb, and this is plus 2 microcoulomb, very much similar to this, and this is 2 microcoulomb. So now in this case, negative and negative charges, this 4 microcoulomb is now negative, this minus 2 microcoulomb towards the right side is negative. So negative and negative, they repel each other. So the force acting on this minus 4 microcoulomb of charge is towards the right side. Again, the charge which is kept towards the left side is positive in nature, and minus 4 microcoulomb negative in nature. So positive and negative, they will attract each other. So in this case, the force which is acting on this minus 4 microcoulomb charge is towards the right side because of this plus 2 microcoulomb charge. So overall force acting on this minus 4 microcoulomb charge is towards the left side. So depending on the position of the charges and the nature of the charge which is kept in between the two charges, the direction of force will change. Let's assume that there are two charges, positive and positive, and instead of keeping the charge on the axis, what we are doing is we are keeping it somewhere here on the equatorial plane, so away from the charges, and assume that these two charges and the next charge, they are forming a triangle, something like this. And it's better if we assume, for simplicity, if this is an equilateral triangle, 60 degree, 60 degree, 60 degree. So now the question is, what would be the direction of force acting between these two charges? What would be the direction of force acting on this charge kept at point, let's say, P? To find the direction of force at point P, we should assume the nature of charge which is kept at point P. So I'm keeping a charge of, let's say, 2 microcoulomb, positive in nature. So at point P, on the vertex of this equilateral triangle, on the top there is a charge of plus 2 microcoulomb. These two charges are already positive. So what would be the direction of force? Now let's try to draw the direction of force. And to draw the direction of force, we need to use the vectors. And another thing, we have to know the individual effect of these two charges at point P. So the force acting at point P due to this charge, let's say this charge is kept at point A and the value of this charge is 4 microcoulomb. So the force acting at point P due to the charge at point A, which is having a magnitude of 4 microcoulomb, will point in this direction. And both the charges are positive, so repulsion, it means the arrow will point away from these two charges. The next one, the positive charge here. So the direction of force due to this, again I'm taking the same charge, 4 microcoulomb charge, which is kept at point B, will point in this direction, something like this. So what we can see is they both are pointing in different direction. And let's give them a name, F1 and F2. No need to give this name, but I'm just giving the name, F1 and F2. So F1 and F2 are two vectors which are pointing in different directions. So at point P, there will be a resultant force which will act vertically upward. Why is it so? Because if we use the vector addition by using the law of parallelogram, these two vectors, they will add something like this. And when they will add, their resultant will point vertically upward. So to solve this type of questions, you should know how to use vectors and how to resolve vectors. This is clear to you? Now imagine instead of using two positive charges, I am using one positive charge here and another negative charge here. They both have same magnitude, 4 microcoulomb and 4 microcoulomb. And there is a point on the equatorial plane somewhere here, and again assume they are forming an equilateral triangle, and this point P is also having 4 microcoulomb, and I will write it somewhere here, 4 microcoulomb of charge. So what would be the direction of force at point P? This is point P, due to this positive and negative charge. So positive, this 4 microcoulomb charge which is kept at point P is positive in nature. This one is positive in nature, 4 microcoulomb, so they both will repel each other. So the direction of force at point P due to this 4 microcoulomb charge would point away from the charge, something like this. And now this one is interesting. This is negative charge of 4 microcoulomb, and this one is positive charge of plus 4 microcoulomb. So the direction of force which will act on this point P would be towards this negative charge, because the force is attractive in nature. So now this point P will experience a force towards the minus 4 microcoulomb charge. So the direction of arrow is towards the charge. Now if you use the law of parallelogram of vector addition, you will find the vectors will get added something like this here in this direction, and the direction of force would be something like this. So the direction of force is acting right side. So what we can say here, when there are positive and negative charges, and due to those two charges we are finding the direction of force somewhere on the equatorial plane, then the magnitude of, then the direction of force acting at that point will be towards the negative charge. This is a general statement, may not be always true. You have to consider the angle and other things as well. So let's change this position of the two charges and keep it something like this. This is negative and here is positive, and 4 microcoulomb and 4 microcoulomb again. On the equatorial plane there is a point P, and this point P is forming an equilateral triangle again. So this is 60, 60, 60. If we apply same concept, what would be the direction of force acting at point P if we are keeping same 4 microcoulomb of positive charge at point P? So as we have done here, the direction of force because of this 4 microcoulomb charge at point P would be something like this. And the direction of force at point P due to this minus 4 microcoulomb charge would be downward at an angle. Now if we add these two vectors, what we will get? We will get the resultant vector something like this. So what we can see is the resultant force is towards the negative charge. In next video, we are going to calculate the magnitude of forces acting between the charges. For example, in this case, or in this case, or in this case.